Good afternoon and welcome to today's Büchi Bits. I am Debbie Repko from Büchi Corporation. I am the Application and Technical Support Manager, and today's topic is going to be spray drying technology. Today's agenda is to provide an overview of spray drying, including a history, what is spray drying, the types of dryers available, the hardware that's included, why the interest and how this can help your project. We'll touch on process parameters, formulation strategies for cannabis and hemp, talk a little bit about our emulsion study, and then we'll finish up with a summary. When we talk about spray drying encapsulation, it's all about particle engineering and size. We have several options within this product offerings. The Nano spray dryer can make particles from 200 nanometers up to 5 microns. We move a little bit further to the B290, which is today's topic, and the particle size range is between 2 to 25 microns. And then we can go larger with our ultrasonic nozzle. The encapsulators can make core shell capsules and beads in the range of 80 microns up to 4 millimeters. And this would be done through a solidification method, not evaporation like spray drying. I'd like to provide a little history of spray drying. It is certainly not a new technology. It was invented in the 1920s into the 1930s, and the first proteins were milk and eggs. The first dryers were wooden and copper, and the key invention was the rotary atomizer. Spray drying is considered the most widely used powder production technology in the world. It is used to manufacture things that we touch every day, like milk, coffee, flavors, more high-end things like vaccine, DNA, blood, and oral solid dosages. And there are many instruments sold globally, worldwide. What is spray drying? It's a widely accepted evaporation method. It's a way to evaporate aqueous organic solutions, emulsions, dispersions, or suspensions to a dry, free-flowing, typically amorphous powder. We can reduce the volume. We can maintain chemical and biological stability. We're not going to break down our THC or CBD. We can define the particle size through our process parameters and our formulation. We could do co-processing. Okay, so I'm going to mix my oil and my encapsulation material to my nano emulsion, and I could agglomerate nanoparticles. This is a depiction of the working principle of spray drying. All dryers have the same working parts, they simply differ in size. We start with our formulation being fed into an atomizing nozzle with gas. We need to heat our spray dryer up high enough to evaporate our formulation. It sprays into the drying cylinder and quickly makes its way to our cyclone. Within that route, it is subjected to an outlet temperature. The fine particles make their way through the cyclone separator into our product collection vessel. This is where the vast majority of our formulation should be. On the back side, I have fine particles coming up through the cyclone into a filter. That filter protects you, the user, and the environment with the fine particles. We go back out, and at the back side, we have an aspirator motor that basically pulls ambient air into the heater. We consider this a semi-continual process. When we spray dry, we will be creating a matrix encapsulated product, meaning we will have oil embedded within the encapsulant material of our choice. This encapsulant material will protect the oil and allow for release into the body and provide proper bioavailability. This shell can also provide taste masking. Our B290 mini spray dryer is considered a traditional laboratory dryer. It has a co-current flow 2-fluid nozzle. The whole system is made of glass so that it's visual. You can see what's going on as a researcher. Spray dryers come with cyclone separators. Our system has a max throughput of 1 liter an hour. I say that it's capable of producing about a 750 gram batch. The smallest sample size would be about 50 mils. We talked about particle size a little bit. 2 to 25 microns is typical. The inlet temperature goes up to 220. The residence time, how quickly we evaporate, is 1 to 2 seconds, meaning it's very quick. And we're capable of spray drying aqueous and organic solvents based upon the configuration of the dryer. Our spray dryer systems can be configured to run open to the environment with water or enclosed environment with organic solvents. The B295 accessory allows the safe operation with safety lockouts for both pressure and oxygen content. It is operated under a nitrogen atmosphere. So success in spray drying is twofold: the process parameters we employ and a robust formulation. On the instrument itself, I have control of some parameters while others are effects. I can set our inlet temperature, our sample feed rate, our atomizing gas, and the aspirator itself. I certainly have control of my formulation. The resulting piece of it is going to be my inlet-outlet temperature, moisture content. It will affect a particle size and morphology. This is a nice worksheet that we use to talk about process parameters and how to develop a process. At the top, we have parameters that I can adjust on my spray dryer, and down the side are the outputs. What am I looking to achieve? Outlet temperature, particle size. Humidity, I want my product as dry as possible, and we all want a high yield. So a nice example would be, if I am most concerned with particle size, I would turn up my spray rate to decrease my particle size. Conversely, if I wanted a larger particle size, I would increase my solid concentration to get me a bigger particle size. So we read this chart. If I turn up the given parameters, the size and the direction of the arrow is the effect on the impact. So let's move into formulation approaches for cannabis and hemp. With some experience under our belts, we have two strategies, one being medicinal, the other being edible. We can use a water-based nano emulsion, so the viscous oils or isolates are further blended using a high-speed homogenizer. Additionally, we will add an encapsulant material to coat our matrix, and these materials can either be made of things like starches, liposomes, plant-based materials, and even vegan. Organic-based formulations will be as if we are borrowing from the pharmaceutical industry, and we're going to use things like biopolymers such as PVP. The ingredients that go into your nano emulsion formulation are your active oil or isolate, typically a carrier oil to manage viscosity, a surfactant, an emulsifier, and these can be of different nature, and of course an encapsulant material. We are going to use a high-speed homogenizer. We have worked closely with the team from Microfluidics that make the M110EH system, and maybe an optional stir plate to get you started. So we embarked on our own nano emulsion application note. We worked in conjunction with Microfluidics, and they made the emulsions for us with oils, surfactants, and carrier oils. Encapsulate material was added directly to several of the nano emulsions, and some were added post-addition as controls. We spray dried 5 different formulations at the same processing conditions. From a post-analysis, we did particle sizing of the spray dried powder. In addition, we did post-analysis of the nano droplets in water by dissolving the spray dried powder into water and assessing how well it dispersed. And I will share a few examples of the control, the full formulation, and actually some data. So I wanted to share a few examples from the application note. Here is formulation number 2, which we consider a control. All formulations were made at 25% solid at a ratio of 1 part oil to 10 parts encapsulant. We use simply CBD from hemp oil, medium chain triglyceride oil as our carrier, and polysorbate 80 as our surfactant to make our nanoemulsion. This was done on the M1110EH microfluidizer. Post-emulsion creation, we added maltodextrin afterwards via a stir plate. Once it was well incorporated, we spray dried. As I said, we were using the same conditions throughout. We talked about process parameters and that I could not set the outlet temperature, but it's an effect. So with each formulation, we recorded the obtained outlet temperature. So the inlet was 170 C, 91 was the recorded outlet. Aspirator was at 90%. I used 9.5 mils per minute from a feed rate for the solution and about 660 liters of gas per hour. These are all considered middle of the road parameters. Here is our full formulation. This was sample number 5. Again, same solids and ratio of encapsulant, CBD from oil, the carrier oil, polysorbate 80, and the maltodextrin was added at the time of the creation of the nanoemulsion. So it's considered a nano suspension. Again, exactly the same process parameters, but note that the outlet temperature is a little lower this time. So to finish up the application note, we had to get some data on pre and post oil droplet size and finished spray dried particle size. We did this in conjunction with RGS Scientific that distributes and sells both the microfluidizers and the MarTech particle size analyzers. So each formulation that contained oil, we measured the droplet size prior to spray drying. We measured the particle size after spray drying. We further took 250 milligrams of spray dried powder and added it to 10 milliliters of water and remeasured the droplets in water. And what was very nice is the droplets remained the exact same size, showing that spray drying will encapsulate the oil and be ready to release at a later time. Another approach to spray drying CBD, CBD isolate, or THC isolate is to do what we call solid dispersion like. This is what the pharmaceutical industry does. Essentially, we are fully dissolving both our oil and our polymer with a proper solvent. The polymer we're choosing is best for the release we're looking for, or the end product, whether it's a tablet or a capsule. Once again, we need to pick a proper ratio of our oil isolate to polymer so that we have proper dosing. I may or may not need a surfactant, and I can pick spray-dried conditions based upon the glass transition temperature of the polymer. Once again, this is going to give us a matrix encapsulation, and this is what the pharmaceutical industry does to encapsulate poorly soluble drugs. So here's an actual example of using THC distillate as a formulation in closed mode with our B295, meaning I'm safely working with solvents. Simply took 5 grams of THC distillate. This work was done at Colorado Cannabis Company. 20 grams of PVP, Colidone 30, or polyvinyl pyrrolidone, if you're not familiar with that. It was fully dissolved in 150 grams of ethanol. That makes it a ratio of 1 part oil or active to 4 parts polymer at about a 16.6% solids. Once again, process parameters are picked high enough to evaporate the solvent at 90 degrees Celsius. The resulting outlet was 55. I used the aspirator at 100%. A little bit lower feed rate, 7.5 mils per minute, and a little bit lower atomizing gas. And this worked very nicely. The THC was completely dissolved. So now we're to the part of the presentation we're going to show the B290 in operation. We have full control of the process through the control panel. We're going to turn up the pump to the speed that we want. All the buttons are push up and down. I'm setting this for 30%, which is about 10 mils per minute. I have a simple peristaltic pump that I'm going to bring liquid to a 2-fluid nozzle with an atomizing gas. We're going to start the system with water. We're going to prime it. We want to make sure that the instrument, the nozzle, is clean. It's going to go into my heated drying cylinder, and we want to look to see that we have a nice atomizing cone, that it's evaporating effectively. I want you to notice that the outlet temperature is set and the inlet temperature comes down with evaporative cooling. We can set this to where we want by our parameters. Once we like how it looks, we're going to start bringing in our formulation. The dried powder makes its way to a cyclone separator into our collection vessel. We want to see good and effective evaporation within the cyclone. Our product is in the vessel. On the back side, we have an outlet filter that will collect our fines. And we have a manometer gauge over the top that shows the pressure drop over the system. We're going to have some product within the drying cylinder, but we want to mostly see a clear cyclone, which is indication of good drying. To finish our process, we're going to put our feed tube back into the water to clear out the tube, and more importantly, to clean out the nozzle. I don't need to do this for a long time, just enough to clean it. We're going to turn down our pump. We're going to turn down our heater. We're going to allow the system to cool down. I'm turning the gas down as well, so I save on that and don't waste it if I have a gas cylinder. Once the spray dryer is cool enough, I usually say around 50 degrees Celsius, I can carefully or safely. At this point, we're going to summarize the benefits of spray drying. We can quickly screen formulations on the lab scale, do small production batches. We can define our particle size and control our morphology through formulation and process parameters. We are doing a one-step encapsulation, meaning we're adding an encapsulant material to our isolate or oils. We have two approaches that we can take. We can do a spray-dried solid dispersion that will increase the bioavailability. In addition, we spoke about doing nano emulsions, more for edibles. I believe this takes greater formulation due diligence versus the organic solvent-based formulations. Success in spray drying is twofold: formulation, due diligence, and the process parameters we employ. Bear in mind, you need to think about proper dosage in your end product, and spray drying is a scalable process. Thank you for attending today's webinar. Below is my email, repco.d@büchi.com. We are going to be answering questions at a later time. Please send them in, and we will get to you as soon as possible. Thank you, and have a good day.